Okay, so today we're going to be we're going to talk about parallelograms, okay, which is a special type of quadrilateral. Our central question we want to be able to answer. And we're actually going to hit two sections today. We're going to do 9.1 and then look at 9.2 because they're very similar, and so we're going to knock both of them out together. So, a central question: what can you conclude about the sides, angles, and diagonals of a parallelogram? All right, so what is a parallelogram? Well, first we're talking about a quadrilateral, right? We all know what a quadrilateral is, polygon with four sides. A parallelogram is a quadrilateral that has two pairs of parallel sides. All right, two pairs of parallel sides. It asks us here to use geometry software to investigate the properties and stuff like that, but we're not going to do that, okay? I think it's just a bit too much to get into there, and plus it's kind of like obvious almost, I think, about what the different properties are and things. So we're just going to jump right into them. So skip the next page, and we're going to go to page 421 and look at this. So we have a theorem here. If a quadrilateral is a parallelogram, so if we have a parallelogram, then its opposite sides are congruent. All right, and then our next example there says prove that the opposite sides of a parallelogram are congruent. And so our friend proof is back, and we're going to do some actually here right now, okay? And it's not too terrible. You guys might look at that and say, oh no, proofs. I thought we were done with that. We're done, right? But no, we're going to take a look at these proofs here. So we're going to start with a given here that ABCD is a parallelogram. So there's ABCD. It's a parallelogram. You can see marked in there the parallel sides there, AB and CD, and the parallel sides AD and BC. And they're going to prove that AB is congruent to CD, so AB is congruent to CD, and AD is congruent to CB. Okay, and actually it's a pretty straightforward proof. I think you guys should be able to do this without too much difficulty at all. All right. So let's take a look at this. So the first statement that we're making is that ABCD is a parallelogram. And Lindsay, what would be the reason that we can say that? Yeah, it's the given. Very good. Okay. Number 2 says draw segment DB. That's a weird statement. And then the reason we can do that is because through any 2 points there is exactly one line. So by drawing this segment DB, what's the special name that we have for this kind of segment that connects two non-consecutive vertices, Hunter? There you go. It's a diagonal. A diagonal. It is a transversal technically too. You're right. We'll get to that in a second. But it's what we learned yesterday. It's a diagonal. That's right. So that is a diagonal. So basically just telling us to draw a diagonal. All right. Number 3 says, all right, AB is parallel to DC and AD is parallel to BC. So from the information that we already stated here, how can we then make that statement? Where is that coming from? Let's go to, so Keegan, how do we know that AD is parallel to BC and that AB is parallel to DC? What piece of information were we given that told us that? I know it's drawn in the picture, but why were they able to draw in the picture here? What kind of shape is this?
It's a parallelogram.
Right, and by the definition of a parallelogram,
that's all.
yeah, opposite sides are going to be parallel. So this is just the definition of a parallelogram. You got it. Okay, that's it. All right, very good. So then Patrick then, so number 4, this is a bit different here. ADB, they're stating that little angle right there is congruent to CBD, so this angle right here, and they're saying ABD, this angle right here, I'll do the double mark, and then it's congruent to angle CDB, which is this angle right there. Patrick, how might we be able to say that those two pairs of angles are congruent? Yeah, that's what we're trying to prove. Remember, we just talked about parallel lines here. So, for example... Okay, so we have parallel lines crossed by a transversal.
Yeah.
So, and this angle's on one side of the transversal, this angle's on the other. What special angle pair do we have here? They're on different sides of the transversal, so they're alternate.
Alternate interior.
There you go. Alternate interior. And I'm just going to abbreviate that here, folks. Alternate interior angles are congruent. And so both of those pairs of angles are alternate interior angles. Okay, since AB is parallel to DC, that means the double arc angles are going to be congruent. Okay, because they're the alternate interiors for AB and DC, and then AD and BC are parallel, so that means the single arc angles are going to be congruent as well. All right, great. All right, let's see here. Oh, she's not here. Maria, DB is congruent to DB. Reflexive property, that's right. Something is congruent to itself. Okay, and so that means that is congruent. And then number 6, it leaves the statement blank, but it says angle side angle triangle congruence theorem. So we have 2 triangles that are congruent apparently here. Adam, can you name what 2 triangles are going to be congruent in this picture? Say it one more time.
ADB and DBC.
All right, so triangle ADB is congruent to, so ADB, and you said what?
DBC.
So be careful how you name it. You can name the first triangle however you want. So you said A, then went down the short side to D, and then across the diagonal to B. So where do we have to start in the second triangle there, Adam?
C.
Yeah, we got to start at C, very good, because they correspond, and then from C to what? So to C to D? So be careful, you went from A to D, so that's like the short side. So C to B, and then to D. And I know that's tricky when they're all like the same, they're kind of sharing a bunch of stuff, but that is what we want to do there. We want to be careful how we name it. So very good. All right, so we proved these 2 triangles congruent, and so then we're concluding here that AB must be congruent to CD, so AB and CD are congruent, and then AD and BC are congruent. And what's the reason that we use when we're trying to show parts are congruent? Zishan, do you remember? Beautiful, very good. You got it in the right order, too. It's just like a bunch of C's, of P's, and T's. I don't know, there's something in there. But that's right, CPCTC. Corresponding parts of congruent triangles are congruent. Since the 2 triangles are congruent, AD will be congruent to BC, and AB will be congruent to DC. And so we've just shown that opposite sides in a parallelogram will be congruent by kind of creating 2 congruent triangles. Okay? Questions on any of that? All right, we'll skip that next question there, and we'll move into the next property. Okay, and we won't prove this one because I think it's kind of redundant. It's almost the same kind of proof, really. So then opposite angles are also congruent. So here's another theorem, another property of parallelograms. So we want to be familiar with this one, right? We want to have this one down. All right, you want to have that one down for sure. You also want to have this one down for sure. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay? And basically, we already have that from the proof that we just did, right? We go back to the proof. We proved these 2 triangles are congruent. So therefore, angle A in this top triangle must be congruent to what angle down here? Let's go to someone we haven't heard from yet. Melissa. Angle A in the top triangle is going to be congruent to what angle down here? Yeah, angle C, right. And so that's opposite angles. We can even go and say that angle B is congruent to angle D, because look at what angle B is made up of. Angle B is made up of this double angle arc, or double arc angle that I have marked there, and the other part of B is the single arc angle. Well, angle D is made up of the same parts, single arc angle, and double arc angle. So D and B will also be congruent. They have to be. And so we don't really need to prove that extra stuff there. Okay? And then the last little property we're going to concern ourselves with today, when it comes to parallelograms, all right? If a quadrilateral is a parallelogram, then its diagonals bisect each other, okay? Bisect each other. So remember we talked about diagonals, all right? And so in this case, the diagonals, if you draw both of them, they cut each other into 2 equal parts, okay? And that guarantees that we have a parallelogram. So let's turn the page there to 420, and we won't prove that one either, because again, I feel like it's similar kind of arguments with parallel triangles, or congruent triangles and things. So we'll just jump to this one. Okay, so we're going to use these properties here of the parallelograms to find each measure. So here for part A, we're asked to find the length of AD. All right, so we're going to use the picture here, and let's see here. John, how might we set up some sort of equation here to find the length of AD? AD is labeled as 7x. So we need to somehow solve for x before we can figure out what AD is. But what can we say, what's the relationship we can kind of set up here? Oh, and by the way, we're told that ABCD is a parallelogram, so all those properties hold true. Opposite sides are congruent, opposite angles are congruent, and then the diagonals will bisect each other. So what can we use here? What can we say that 7x is going to relate to in this parallelogram? Yeah, and specifically, we're going to say that 7x is what in relation to the 5x plus 19? So it's parallel sides, but how can we like relate these two things? Yeah, so we'll say they're going to be equal. So 7x equals 5x plus 19. And then to solve this, what would we do here, John? Yep, and so we're left with 2x equals 19. And then what? Divide by 2. And yep, we get 9.5. So is our final answer here 9.5 then, John?
No, you have to put it back in for that.
Yes, very good, right? We were asked in the directions to find AD, not x. We're going to use x to get AD, but we have to figure out what the length of AD is. So it's going to be 7 times 9.5. Questions? Yeah, go ahead. Say hi to your friend for me out there, too. All right, 66.5 is the length there. Okay. 66.5 is the length. So do 7 times the 9.5. Okay. Yep. All right. How about letter B here? So we're supposed to find the measure of angle B. So Mason, here's angle B right here, 6y plus 5. What's the relationship we can set up there to kind of?
You can do 6y plus 5 equals 8y minus 17.
Very good. Right. Opposite angles in a parallelogram have to be congruent. So we'll set those two pieces equal, and then what? Okay, so we get 5 equals 2y minus 17.
And add 17.
Add 17, so we get 22 equals 2y.
And then divide by 2.
So y is 11. And the final answer is 11?
No.
That's right.
Plug it back in for y.
Very good. Okay, so we plug it back in here. So it'll be 6 times 11 plus 5. So what is that? 71. Okay. So angle B is 71 degrees. Okay. So angle B is 71 degrees. Angle D is also 71 degrees. How can we maybe go about solving for like angle C or angle A here? Yeah, Evan?
Well, 71 plus 71 is 142.
Okay.
Divide 142 from, not divide, subtract 142 from 360.
Okay, because all the angles in a parallelogram or in any quadrilateral have to add to 360. So, okay, hang on a second. That's kind of the number 7 down here, by the way, so I'll just go ahead and do it right here. So 360, take away 142, which is 70, both 71s there. So 218?
Yeah, and then you divide that by 2 because the 2 angles have to be congruent.
Right, A and C we know have to be congruent. They're going to be equal, right, because they're opposite each other. And so if both of them have to add up to 218, we'll divide those by 2, and we get 109 degrees. So each one of those, angle A and angle C, must be 109 degrees. Can anyone see a different way to get angle A and C besides doing it that way? What other relationship do we have? Yeah, Evan?
Well, they're, I can't remember, well, if you add, subtract 71 from 180 because they're opposite angles.
Yes, so supplementary, I think is the word you're looking for. Supplementary, right. So if you look here, like, for example, angle D and angle C, what special angle pair is that? We have a pair of parallel lines, right? This is a parallelogram, so that's parallel to that. Crossed by this transversal CD. These are same side interior or co-interior or, you know, consecutive interior angles. So these are going to be supplementary, right? So 180 minus 71 gives you that angle. 180 minus 71 gives you that angle too. So yeah, another way to get the 109 there. Okay. Questions on anything so far? Pretty straightforward. All right, go ahead and then try 8 and 9 then. Give those a shot. All right. Make sure you're answering the question that's being asked, too, by the way. Okay? That is correct, but I don't think that number is.
Oh, for this one? So, right, you're gonna find the whole length, but all you're getting is these pieces. So you could, but the problem is when you add them together, you have something that's equal to, right? So that's, well, can we do that? Okay, is the angle we're talking about here? So I mean, you were right when you said that these two pieces equal to each other. But why? What property were you using? Remember? This is, what is this thing called that connects the like non-consecutive vertices? What do we call it? So this is rhymes with diagonal. Yes, you got it. So what's true of the diagonals and the parallelogram? Diagonals, parallelogram. Okay. They split each other into two equal parts. So this diagonal here is cutting this one to this part to this part. So that's making it equal. Okay. Then I go ahead and do that. So this is correct. You have z minus 4 equals 4. So you add
sure.
4, right?
Right.
You have 5x plus 9 equals negative 6. So you subtract 9 from both sides, that'll give you a negative 15 there. Okay.
And then you still be careful because you're not asked for the measure of z or x. You want to find the measure of QR and PR. Those are good. Yep. So once you have those, Patrick, you're going to find QR and PR. Okay, so 14 you plugged in right here, right? But what is x plus 9? That's just t. Oh, you want PR. Okay. So here should be our answers. 8, 20, PR for number 9 is 28. So 20 and 28. Okay. So again, our directions told us PQRS is a parallelogram. We need that fact, okay? If we are not told PQRS is a parallelogram, we cannot use these properties, right? So if we're just told, here's the shape, solve for these sides, we're kind of stuck unless we're told that PQRS is a parallelogram. All right. So, there's that. All right. Any questions on any of that right there? All right. So we're going to get some assignment problems here in just a second, but I'm going to skip on to the next section real quick. So if you want to skip to page 433, all right, we're going to just jump to these, and again, this will be really quick. It shouldn't take very long at all. Okay, to get through these because it's basically, well, you'll see here what we're going to do. Okay, so page 433 is where we are. And so for this section, we're talking about the conditions for parallelograms. So now it says, what criteria can you use to prove that a quadrilateral is a parallelogram? So instead of starting with the idea that if you have a parallelogram, then opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. Now we're going to take those properties and we're going to say, oh, since the opposite sides of this quadrilateral are congruent, then this shape must be a parallelogram. Or, since the opposite angles of this quadrilateral are congruent, then this shape must be a parallelogram. Okay, so we're going to kind of go backwards now, using those properties, if they exist or if they occur, to then say the shape is a parallelogram. So, for example, in this theorem right here, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? So, we're not going to run through the, actually the proof is like, it's super easy, but we're not going to worry about that, okay? But basically it involves congruent triangles again in those parallelograms, but we're not going to worry about proving those, okay? Just because I want to give you guys, I feel like, again, it's kind of beating a dead horse here. All right, likewise, if one, now this is a different kind of property. We didn't talk about this, I mean, this one didn't really show up in the previous chapter, but if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So if you have one pair of opposite sides of a quadrilateral, and those sides also happen to be congruent, then the quadrilateral must also be a parallelogram. Okay. But likewise, we also have, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so that was that property we saw. And then finally, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, so turn the page there, and let's look at page 437. Okay, and we'll just really quickly do some examples. Yeah, just two examples here, I guess. These two examples. Okay. Now I'll let you guys get started on the assignment because it's pretty straightforward here. All right. So example 4, the directions change slightly from what we've been doing. Now it says, show that each quadrilateral is a parallelogram for the given values of the variables. All right. So in letter A, we're told that x is 7, y is 4. So that means here that, for example, this side BC, it's x plus 14. Well, we plug the 7 in, that means it's 21, right? And then AD, well, again, if x is 7, that means this side is 21. So far, so good, right? Opposite sides are congruent. Let me just check this other one here. So we plug in 4 for y, we get 20 minus 4, so 16. And then 2 times 4 is 8, plus 8 is also 16. So is this quadrilateral a parallelogram? Yes, because why? Go ahead, Maria. What's true? Opposite what? Opposite sides are congruent or equal, so therefore, both pairs of opposite sides are congruent, therefore it's a parallelogram. That's all you got to say. All right, let's look at B. B, I'm going to need my calculator because we got some weird numbers here. So we'll say Z is 11, so I'll just type in here 9 times 11 plus 19, we get 118 degrees. 11 times 11 minus 3, also 118 degrees. 14 times W is 4.5. So 14 times 4.5 minus 1, 62 degrees. And then 12 times 4.5 plus 8. Whoop. 62 degrees. So is this quadrilateral a parallelogram? Yes, because what? Why in this case? Opposite angles are congruent. Yep, exactly right. Okay. Yeah, and that's it. Okay? Questions on any of that? So that's pretty much it. I'm not going to have you guys do these two problems here because I think this stuff is pretty straightforward, so I won't worry about that at all. Okay. Instead, let's get you guys started on your assignment. Okay, now tomorrow I will not be here. Sorry for the late notice. I am still going to have you guys try to learn stuff. All right, I'm going to try and record something and then have our sub play it for you, so hopefully that works out. We'll see.